We're on a square concrete platform positioned offshore, ideal conditions for a ballistic test that focuses on precision and impact analysis. On the platform, near the edge, there's a smaller concrete block. This is where we've arranged the firearms and ammunition used in the experiment. Each item is placed to give a direct visual reference for its size and scale. Further down the platform, two larger concrete blocks stand side by side. These are the primary targets for the test. Each block is made of solid concrete and positioned to receive direct hits from the selected ammunition. The first round used in the test is the .22 long rifle, fired from a precision bolt-action rifle. This cartridge is lightweight and low-powered, commonly used for target shooting and small game hunting. But how does it perform against solid concrete? In slow motion, the bullet makes contact with the concrete surface and shatters instantly. Tiny fragments scatter outward, and a faint dust plume rises from the point of impact. The penetration depth is measured at approximately 2 centimeters, confirming the round's limited effectiveness against hardened material. The second round in the test is the 9 by 19 millimeter parabellum, commonly known as the 9 millimeter. It's fired from a pistol, and compared to the .22 LR, it delivers significantly more energy on impact. But how does it hold up against solid concrete? The bullet strikes the concrete block with a sharp impact. Just like the .22 LR, the projectile fragments on contact, scattering small pieces outward. The penetration is slightly deeper, measured at approximately 5 centimeters. The third round in the test is the .357 Magnum, fired from a revolver with a 6-inch barrel. This cartridge is known for its high velocity and strong terminal performance, often used for hunting and personal defense. It's slightly bigger than the 9 millimeter, but it's faster, with a muzzle velocity of 450 meters per second. It has a weight of 10 grams. The bullet hits the concrete block with a sharp, focused impact. The surface cracks around the entry point. The penetration depth is measured at approximately 7 centimeters, making it the deepest so far in the test. The crater is narrow but clean, showing the round's ability to transfer energy efficiently into the target. The fourth round is the .308 Winchester, fired from a precision rifle. This cartridge is widely used in military and hunting applications, known for its long-range accuracy and high kinetic energy. It has a whopping 820 meters per second muzzle velocity, and it has a weight of 9.7 grams. The bullet strikes the concrete with a violent burst. A large cloud of dust erupts from the surface. The penetration depth is measured at approximately 9 centimeters, but the impact zone is wider and more chaotic than previous rounds. The concrete surface shows signs of cracking and spalling around the entry point. The fifth round in the test is the .50 BMG Browning machine gun, black tip M2 armor-piercing projectile, fired from this golden long-range precision rifle. This cartridge is designed for extreme power and penetration, commonly used in anti-material rifles and heavy machine guns. The projectile has a weight of 45 grams and has a muzzle velocity of 850 meters per second. The bullet hits the concrete block with massive force. A violent burst of dust and debris erupts from the surface, and the impact zone expands instantly. The penetration depth is measured at approximately 15 centimeters, with visible cracking and spalling across the front face of the block. Unlike previous rounds, the damage is deeper and more concentrated, with signs of shock stress radiating outward from the entry point. You can see the hardened steel core in the bottom left corner of this frame. The sixth round in the test is the Hexa Special, a custom-engineered projectile by Hexa Ballistics made of pure tungsten and steel. Despite its compact size, this round is extremely dense and built for maximum penetration against hardened targets. It has a weight of 216 grams and a muzzle velocity of 850 meters per second. As you can see, this round and the precision rifle that fires it are custom-plated with exotic materials. The Hexa Special hits the concrete block with overwhelming force. A dense burst of dust and debris erupts from the surface, and the impact zone expands instantly. The penetration depth is measured at approximately 20 centimeters, the deepest of the entire test. The seventh round in the test is the 30 by 173 millimeters, a high-velocity autocannon cartridge typically used in platforms like the Mark 44 Bushmaster II. This round is designed for anti-vehicle and anti-structure roles, delivering massive kinetic energy and often equipped with specialized payloads. It has a weight of 400 grams and a muzzle velocity of 1,080 meters per second. The 30 by 173 millimeter projectile strikes the concrete block with overwhelming force. A violent explosion of dust, debris, and concrete fragments erupts from the impact site. The penetration depth is measured at approximately 25 centimeters, with extensive cracking and spalling across the entire front face of the block. The shockwave visibly distorts the surrounding structure, and the crater left behind is wide and jagged. The eighth round in the test is the 40 by 365 millimeters, a powerful autocannon cartridge typically used in anti-aircraft and anti-armor systems. This round is designed to deliver extreme kinetic energy and often carries explosive payloads, making it one of the most destructive conventional projectiles in service. It has a weight of 1 kilogram and it has a muzzle velocity of 1,000 meters per second. Large, fast, and engineered for maximum damage against armored and fortified targets. But how does it perform against solid concrete? The 40 by 365 millimeter projectile slams into the concrete block with devastating force. A massive eruption of dust, debris, and concrete fragments fills the frame. It hadn't fully penetrated the first block, but it had enough energy to destroy it, with the entire front face of the block shattered and radial cracks extending across the structure. After testing 8 increasingly powerful rounds, from the lightweight .22 LR to the devastating 40 by 365 millimeter autocannon shell, the results are clear. Concrete can withstand a surprising amount of energy. But even with deep craters and shattered surfaces, the second blocks remains basically intact. To push the limits further, we introduce a new contender, the 76 by 636 millimeter round. This is not a standard cartridge. It's a heavy-duty naval-grade projectile, typically fired from deck-mounted cannons or armored vehicle turrets. Designed for anti-ship and bunker-busting roles, it delivers extreme kinetic energy and is capable of breaching reinforced structures. It has a weight of 7 kilograms and a muzzle velocity of 900 meters per second. The 76 by 636 millimeter projectile slams into the block with overwhelming force. A thunderous shockwave ripples through the structure as the front face disintegrates. Dust, debris, and concrete fragments erupt in all directions. The penetration depth exceeds the first block and reaches the second. That block suffers catastrophic damage, cracking, spalling, and collapse. You can see the heavily damaged round sliding on the ground after having destroyed the blocks. The final chapter of this ballistic test features a round unlike anything we've fired before, the Hexa Inexorable. Designed by Hexa Ballistics, this projectile represents the pinnacle of kinetic weapon engineering. Measuring 400 millimeters in length and 95 millimeters in diameter, it's forged from pure tungsten and plated with exotic materials to withstand extreme temperatures and impact stress. Weighing in at 127.5 kilograms, each round costs over $500,000 to produce. To accommodate its destructive potential, we've added a third concrete block, positioned farther downrange. But even that may not be enough. The Hexa Inexorable tears through the air at 1,100 meters per second, striking the block with a force that defies comparison. The impact is instantaneous and catastrophic. The concrete disintegrates into a cloud of dust and debris, and the projectile doesn't stop. It continues on its path, exiting the rear face of the block and vanishing into the distance, and fragments rain down like shrapnel. No previous round came close to this level of destruction. If you enjoyed watching things explode in slow motion and learned something cool today, consider hitting that subscribe button. It means a lot, and it helps me bring more videos straight to your screen. Thanks for watching.